Hi, and welcome to video 4 of 4 videos for section 1.1. This specific video is just examples of the repeating decimal problems. Give you guys a moment of honesty here. So it's been a couple years since I taught Math 126, and I know a couple things have changed, and I'll make sure to dial that in for you guys. But one of the things that was a problem that always showed up on finals, so thus I had it on my midterm exams and so forth, was the repeating decimal. Being able to convert a repeating decimal into a fraction. And in the book, it's just like a little side note in chapter 1. They don't even go into it too much, but because it's stressed within the department, I want to make sure you guys know how to do this. So we looked at 0.3 with the 3 repeating, that was 1/3. This example here, let's say I want to find the fraction for 1.23 with the bar over the 3. So the bar over the 3 means what? It means the 3 repeats. Not anything else in this problem is repeating other than the 3. So if you want to pause the video, if you sort of understood what we did in video 2, I believe it was, see if you can solve this, find the fraction, that's great. If not, if you want to follow this one through, we'll do another example after this. There's 2 examples we're going to do. So the first thing we did is what? We said x equals this guy, 1.23, and the 3 is the repeating piece. So I'm going to put a few of those in. Why? Because I need to make sure that the part I'm subtracting, they all equal up. So if I do that though, let's look at this. So if I just said x is equal to this guy, remember that I want everything after the decimal to be the same. Well, no matter what I multiply this guy by now, let's say I do 10x. 10x is what? It means the decimal moves 1 place. So that gives me what? 12.3333. It keeps repeating. So that's okay, but what do I have here? These guys aren't all the same. All of this to the right of the decimal has to be the same. So I can't just start this problem by saying x is equal to that. I mean, I can as my first step, but I'll see real quick that that's not going to work out. So the one I would have to start with here is 10x equals what? So if this is my x equals, 10x would be 12.3333. And that tells us what? When we're doing these problems, the very first value that we can use is the one that puts the decimal between a non-repeating number and the repeating number. So sometimes, like when we had 0.3, we could just start with that as our starting one. X is equal to that value because it was already the repeating portion. In this one, we couldn't do that because we would have ended up with a 2 on the right side, and that would have caused us problems. So I still need one more number so that I can do my subtraction. So I'm going to go what? To the next value up, 100. So if I do 100, that means what? It means the decimal moves 2 places in the original. So that's 123.33333, which is great because I have everything on the right of the decimal is all the same. Remember, this must be the same. Once it is, I can do subtraction. So 100x minus 10x is 90x. And 123 minus 12 is 111. And then what happens here? All the decimal pieces become 0. So now it's an algebra problem. I want to divide both sides by 90. So x is 111 over 90. Simplify this if we can. I don't know if you guys know the division tricks. If I add up the numbers, 1 plus 1 plus 1 is 3. Since 3 is divisible by 3 and 9 plus 0 is 9, 9 is divisible by 3, I know that I can divide the top and the bottom by 3. And when I do that, 111 divided by 3 is 37. And 90 divided by 3 is 30. And then that's it. That's as far as I can simplify it. So those simplification, I'm trying to remember if that's in, I'll see if I can find that shortcut sheet for you guys. That way if you're having to do any reducing, it'll make it a little bit easier for you. But that's it. So is there any way to check this? Well, sure. Just divide 37 by 30. If you do that, if you do it on a calculator, if it's on your homework or something, if it's on an exam, do it long division by hand, you should get 1.233333. And as long as you do, you know that you have the right answer. So second example we're going to look at, same idea, find the fraction 4, 0.14, and now the bar is repeating on two numbers. It's repeating on the 1 and the 4. So this is the same thing as 0.14, etc., etc., etc. The 14, the 1,4, just keeps repeating. So again, if you want to give this a try, go ahead, hit pause, come on back, we'll work it through anyhow. And if not, if you want to follow it through for this one and then maybe try some from the book, that's fine. So if we say this is my value x, well, can I use this as a starting value? And in this case I can, right? Because the decimal is right before the repeating part, and that's what I need. So I can say x is equal to 0.14, going on and on and on. Now, though, I have to be careful because I have to get from one repeating part to the next repeating part. So I have to move how many places? I have to move 2 places. So if I just said 10x, so let's try it to see what happens. 10x is equal to what? Well, it moves the decimal 1 place, so I get what? 1.414141, and that's not the same. These on the right side have to be the same. It has to be 141414, 141414. So I can't use 10 in this case. I actually have to multiply it by 100 because I need to move it 2 spaces. So if I say 100x is equal to what? If I move it 2 places, 14.141414. And now what's on the right side is the same, so that's fine. Do my subtraction. 100, don't forget there's like the invisible 1 here. 100 minus 1 is 99. X. 14 minus 0 is 14. And then the rest cancels out. So divide both sides by 99. So x is equal to 14 over 99. That's as far as we can go. We won't simplify anymore. So that's our answer. And again, you can check it. If it's on homework, do 14 divided by 99 and you'll get the 14 repeating. If it's on an exam and you have some extra time, you want to check your work, just do it by long division. Make sure you get the right answer. So that's it. Just 2 examples for you, kind of things to be careful of, some of the methodology of how do we solve these kind of problems. That wraps up section 1.1. Come on back and we'll look at the videos for section 1.2.